Okay, so this one looks quite complicated. So if we use L'Hopital's rule right away, this is gonna take absolute ages. So we're not gonna do that, but instead, we're gonna use some really common limits. One of them, there's no need to memorize these, but if you use that for so long, you'd know these are really common, and you just memorize them at the end of the day. Is 1, and then 1 minus cosine x over x squared is, I believe, 2. This one I believe is 2 because of L'Hopital's rule. So let's do that straight away. Sine x over x cubed, tangent 3x over 3x squared. I'm going to move this to the side. That's way too basic. And obviously we have 1 minus cosine 5x squared. And then we have to deal with the extra terms. So there's an extra x squared here. There's an extra 3 squared x squared here. So I believe that's 3 squared x to the power 4. 3 squared, yep, that should be 3 squared, my bad. And then here there's a 5 to the power 4 x to the power 4. And that's the entire limit. And then obviously we can split limits when they're multiplied. Cubed tangent 3x over 3x squared. Limit 5x squared. Whoops, that's absolutely wrong. 1 minus cosine 5x squared. And then last but not least, limit in constant in the limit is 9, 6, 25. It's just himself, the constant. So 1 cubed times 1 squared times, this is flipped, so it's 1/2. 1/2 squared, 9 over 625. Sorry about that. That's 1/2. And so this should be 2. That's 2 squared, 9 over 625. I'll prove these later. I'll prove these later in the same video. So that's 36 over 625. And that's the exact limit. But these could all be proved by L'Hopital's rule. So let's do that right now. Sure, let's do that right now. So obviously limit sine x over x. Sine 0 is 0. Obviously x equals 0. So we could use L'Hopital's rule. That's cosine x over 1, which is why this is 1. Limit tangent x over x is same result over 1. Obviously cosine 0 is 1, flip that as 1, squared is also 1. And then limit 1 minus cosine x over x squared is just, I believe, is in this format. So we could use L'Hopital's rule, and we have Negative cosine gives sine x over 2x in a limit. How did I forget that? That was quite stupid. Sine x over 2x, which is 1 over 2 limit of sine x over x. And obviously that's just 1 over 2. If you flip that, that's definitely going to be 2. And that's it for this video.